देवी महालक्ष्मी पॉलिटेक्निक टिटवाळा, डिपार्टमेंट ऑफ कंप्यूटर इंजिनियरिंग and information technology, semester 3rd, subject database management system, subject code 22319, POD. For learning outcome of this video: data independence, overall structure of DBMS, and data modeling. Now, Chapter 1, Database System Concept. This is for CO3I, and IF3I is the basics of database and architecture. But common topic is data independence. So let's see the data independence. The ability to modify schema definitions in one level without affecting schema definitions in the next higher level is called as data independence. It is defined as a property of DBMS that helps you to change the database schema at one level of a database system without requiring to change the schema at the next higher level. It helps you to keep the data separated from all programs that make use of it. You can use this stored data for computing. Types of data independence. The first is physical data independence. It is the ability to modify the physical schema without causing programs to be written. Modifications at the physical levels are occasionally necessary to improve the performance. It means we change the physical storage levels without affecting the conceptual or external view of the data. The new changes are absorbed by mapping the technique. Physical data independence helps you to separate the conceptual levels from the internal or the physical levels. It allows you to provide the logical descriptions of the database without the need to specify the physical structures. Compared to logical independence, it is easy to achieve the physical data independence. You can easily change the physical storage structure or devices with an effect on the conceptual schema. Any change then would be absorbed by the mapping between the conceptual and internal levels. It is achieved by the presence of the internal levels of the database and then the transformations from the conceptual level of the database to the internal level. Some examples of changes under the physical data independence is using a new storage devices like a hard drive or the magnetic tape. The modifying the file organization techniques in the database and the switching to the different data structure, as well as the changing the access methods are here. The next is the logical data independence. Logical data independence, it is the ability to modify the logical schema without causing application programs to be written. Modifications at the logical levels are necessary whenever the logical structure of the database is altered. For example, when money market accounts are added to the banking system. Logical data independence means if we add some new columns or remove some columns from the table, then the user view and the program should not change. Consider two users, A and B. Both are selecting the fields employee numbers and the employee name. Some questions regarding this topic. The MCQs are here. The first is the capacity to alter the database schema at one level without altering any other level schema is classified as. The first option is the data mapping. Second, data independence. Third, data dependence. and 4 is the data transformation. Then I will repeat this question again. The capacity to alter the database schema at one level without altering any other level schema is classified as, answer is data independence. Then the second question is the type of the data independence in which the internal schema can be modified without modifying the conceptual schema is classified as, the first option is logical data independence. Question third. The physical data independence is ability to modify dash 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 without causing application program to rewrite. First option, conceptual schema. Second, logical schema. Third, physical schema. And fourth is the logic. Next topic is overall structure of the DBMS. A database system is partitioned into modules that deals with each of the responsibilities of the overall system. The functional components of a database system can be broadly divided into the storage manager and the query processor. These are the components of the database systems, and the storage manager is important because the database typically requires a large amount of storage space. The query processor is important because it helps the database system to simplify the facilitate access to a data. And the DBMS acts as an interface between the user and the database. The user requests the DBMS to perform the various operations, just like the retrieve, insert, delete and update on the database system. The components of the DBMS perform these requested operations on the database and provide the necessary data to the users. Now, we discuss about the structure of the DBMS. The following components are the DDL compiler. DDL compiler converts the DDL commands into the set of tables containing metadata stored in a data dictionary. The metadata information in name of the files, data items, storage, details of each file, mapping informations and constraint extraction. Next is the DML compiler. The DML commands such as the retrieve, insert, update, delete, etc. from the application programs are sent to the DML compiler for the compilation. It converts these commands into the object code for understandings of the database. In this, we translate the DML statements in a query language into an evaluation plan consisting of the low-level instructions that the query evaluations engine understand. A query can usually be translated into any of a number of alternative evaluation plans that all give the same results. The DML compiler also performs the query optimizations, that is, it picks the lowest cost evaluation plan from among the alternatives. In query evaluations engine, which executes low-level instructions generated by the DML compiler. The object code is then optimized in the best way to execute a query by the query optimizer and then sent to the data manager. In the data manager is the central software components of the DBMS, also known as the database control system. The main functions of the data manager is it converts the request received from query optimizer to machine understandable form. It makes actual request inside the database. It controls the handling buffers in the main memory as well as it enforces constraint to maintain the consistency and integrity of the data. It synchronizes the simultaneous operation performed by the concurrent users and also controls the backup and the recovery operations. These all things happens in the data manager. And now the next is the data dictionary. It is a repository of descriptions of the data in the database. It contains the informations about the data. Then what is data? The data is the names of the tables, names of the attributes of each table, length of the attributes and the number of rows in each table. Relationship between the database transactions and the data items referenced by them, which are useful in determining which transactions are affected when the certain data definitions are changed. The detailed information on the physical database design, such as the storage structure, access path, files and record sizes are here. And then the access authorizations is the descriptions of the database users, their responsibilities and their access the rights. It is used to actually control the data integrity and the accuracy. It may be used as an important part of the database. The main functions is the storage manager. It is a program module that provides the interface between the low-level data stored in the database and the application programs and queries submitted to the system. The storage manager is responsible for the interactions with the file manager. The raw data are stored on the disks using the file system, which is usually provided by a conventional operating system. The storage manager translated the various DML statements into low-level file system commands. Thus, the storage manager is responsible for the storing, retrieving and updating data in the database system. Next is the transaction manager. A transaction is a collection of the operations that performs a single logical function in a database application. Each transaction is a unit of both automaticity and consistency. Transaction manager ensures that the database remains in a consistent, that means correct the state despite system failures. For example, the power failures and the operating systems the crashes. That time the transactions are the failure. Some questions regarding the overall structure of DBMS. The first question is, a DBMS query language is designed to the first option, the support end users who use the English like commands. Second option, the support in the development of the complex application software. Third option, specify the structures of a database. And fourth is all of the above. So answer is all of the above, because the all are happening in the database query language, and it is the designed for the end users who has English like commands, support in the development of the complex application software, and as well as they specify the structure of a database system. Then second question is, the transaction processing is associated with everything below the accept. Option first. Question number third. Dash 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 represents the structures of the database in a formal language acceptable by the DBMS. First option is the database schema. Second, AR diagram. Third, database table. And fourth is the none. I will repeat the question. Now, next topic is the data models. The data models, the process of analysis of data objects and their relationship to or three data objects is known as the data modeling. It is the conceptual representations of data in the database. It is the first steps in the database Designing the data models define how data is connected to each other and how they are processed and started inside the system. A data model provides a way to describe the design of a database at the physical, logical, and view levels. There are the different types of data models are here. The relational model. In next slide we will discuss about the different types of data model. Student, if you have any query, you can put message on the WhatsApp.